And can you scroll it to that? And you can scroll.
Done, Sarah?
Yes, ma'am.
All right. See, one last topic that I just wanted to complete, that's why I took this extra class, is horizontal projection. Because from now Tuesday onwards, now I want to start with the next lesson, that is your laws of motion. See class, horizontal projection is actually very easy in comparison to your angular projection. You people have studied angular projection so much in detail, right? You know the entire derivation, you have seen all questions. So it is very similar to it, but since the angle is missing, so many things become easier. See, horizontal means what? Horizontal projection means no angle is being made with the axis. No angle is being made with the axis. No angle means zero. Like something has been projected like this. From, suppose, let's say this is a building. From the window of a building, a ball has been thrown. So this would be the path. Now the path won't be like this because the building is already here. If you are throwing something, so it will go like this. So this is known as horizontal projection. This is no angle that is being made, means the angle that is formed is 0 degree. Right? There isn't any angle that is formed. Here we used to consider this angle that complicated and what we called it as angular projection. All right, so here you will be again having an initial velocity, everything will be there. See, you will having the path along x-axis also, you will have the path along y-axis also. And I've told you several times that since we are studying motion in 2 dimensions, that's why you need to solve everything along x-axis separately and y-axis separately. Here also we will be doing the same thing. So, and this becomes the height then. The way in your angular projection, this was the height. Now you just have this part. So this remains still, it remains the height. Right? Range of motion was entire, but now range of motion will be just this part. That's it. Equation of trajectory. Remember, it was a very long equation in angular projection. X tan theta minus G. And one more thing, class. When you are talking about trajectory, that is path followed, it means it doesn't include your range of motion or your height. We are talking about this path that has been covered. See, this path that is covered. This is what is known as equation of trajectory. This is what is your equation of trajectory. Means the entire path that has been covered. So how to find this? Again, same thing along x-axis and along y-axis, we'll solve it. How will you solve it? Conditions will remain as it is. See, ux along x-axis, initial velocity does not change. This is what we had studied. What are the conditions of a projectile? When do we call a motion as a projectile motion? When the initial velocity does not change along x-axis. Along y-axis it can change. But look, do we need to have the components along x and y now? Can you notice that the velocity's component along x-axis is only this u? Earlier, we had this as the angle with u as the initial velocity. So we had to break up into its component ux and uy, from which ux came out to be q cos theta and uy came out to be u sin theta. But now, this is your initial velocity. So why do we resolve components? When we were doing resolution of vectors, we had studied, no, we resolve components to get all the vectors along x and y axis or perpendicular to it. Here, if they are in a plane, like u was in a plane, but right now u is along its axis only, that is along x axis it is, so ux will be u only. And is there any component, y component? Uy isn't present, ui is not existing over here. So you just have to keep in mind the same thing as we are using here, but the terms are simple because you do not have cos theta or sin theta over here. So ux will be initial velocity u only, and acceleration along x-axis. What is acceleration along x-axis in projectile motion?
0.
0. Very good, Sarah. It is 0. You do not have acceleration, neither you have acceleration nor you have force. And obviously, if you have no acceleration, force won't exist. Displacement, yes, that we do not know. So what will it be? See, if you use the equation x is equal to ut plus half at square, this term will be 0. So your x is going to be ut. Remember, in the derivation of angular projection also, we have done the same thing. That time your t came out to be x by u cos theta. Right now, time is coming to be x by u. Same thing along y-axis, uy. Uy isn't existing here because there is no component of velocity along y-axis. Entire velocity is situated along x-axis. We don't even need to resolve the vectors. Acceleration, yes, acceleration along y-axis. Along this y-axis, if a body is moving in air along y-axis, which acceleration comes?
G minus 2.
G, yes, acceleration due to gravity is the acceleration that is existing. Very good, acceleration due to gravity. So you have G, that is acceleration due to gravity existing. Now we want to find out y. So let's write the equation of y. Y is equal to ut plus half at square. This time this is y, acceleration y. Here it was x. So y will become this term, this is 0, half, acceleration is g, time is t square. See, Sarah, right now you won't write it as minus g because what is your sign convention? Let's say downwards we have taken it as negative. So if acceleration due to gravity is negative, displacement will also be negative because the body is coming downwards. So they will cancel each other and you will get plus. Or if you take downwards as positive, then also they will be plus. We take one direction as positive, other as negative. But here what is happening? Had there been an initial velocity, then we might be using minus g over here and making this as plus, or making this as minus and making this as plus. Is this clear?
Yes, ma'am.
All right. So this is the equation of trajectory. Now, one more thing we can do in this step only. We
you
can
explain
substitute
again?
the value of time from here. That becomes x square by u square. You can notice how simple your equation is as compared to your angular projection. You just have to remember this equation. Half gx square by u square. No sine square component is there. No cos square component is there. Quickly note it down. Then we'll write the derivation for time period. Yes, Harsha, I'll explain. See, G, you can take negative. Let's talk about sign convention. Let's say I have taken sign convention upwards as positive and downwards as negative. Fine. Now acceleration due to gravity is acting in downwards direction. So according to my sign convention, this will be negative. One more thing, not just this will be negative. Along with this, my y will also be negative, minus y. I'll put. Why? Because my displacement is also negative. No, if I'm taking downwards as negative, then displacement is also negative. So actually this negative sign means minus y is equal to minus half gt square. This minus and this minus have cancelled each other. All right. And suppose if you take the sign convention opposite, you take downwards as positive. In that case also, this will be positive and this will become positive. Now it's clear, Harsha?
Yes, ma'am.
All right. Note this down, then a very small derivation again for time period. Please. Others have also completed. Harsha, you have written till here?
Yes, ma'am.
All right. From here, Martin, you can see after towards the end of the class, just let me know, Martin. You can then take the screenshots of these. Just one topic we have started, that is equation of trajectory. We are discussing horizontal projection. So here the benefit that is provided to us is that we do not have to resolve our velocities. Why? Because your velocity, suppose the body is moving like this. This is what is known as horizontal projection, where the body is being projected horizontally. So the initial velocity is parallel to your x-axis. So now you don't even need to resolve it. Earlier, we used to have velocity along x-axis. We used to have velocity along y-axis. We had this velocity in a plane. So we resolved it along x-axis. We resolved it along y-axis. We had cos theta from here. We had u sine theta from here. So from this entire thing, we are now saved. We just have this velocity along x-axis, that's it. Along y-axis, we do not have it. And this becomes the height now, and this is the range. Now, talking about time of flight, see, suppose, let's say this point is O point, and this point is A. Time of flight means the entire time taken by the body to move from O point to A point. It can be in minutes, it can be in hours, it can be in any unit. SI unit will always be seconds, but when the body starts its motion from this point and moves to point A. So this is time taken from O to A. So we use the equation y is equal to ut plus half at square. Now uy we are talking about ay. So do we have any velocity along y-axis? No. So similar to the previous case, uy will be 0, not ux. This is uy. Uy will be 0. All right. Y, what is your y? The displacement that is occurring in this duration. Displacement is y only. Trajectory is this, but displacement is the shortest path that covers from O to A point. Shortest path is this only. So y, that is your displacement, is actually the height. So your displacement, this isn't y, this is actually the height. Yes, next, acceleration along y-axis we have discussed. This is acceleration due to gravity. And coming to t is your time period that we are calculating. So see, if uy is 0, this part becomes 0. So h is equal to, this is half. Now see again, displacement and acceleration due to gravity both are acting downwards. So I am taking downwards as positive. So that's why I'm taking h also as positive and acceleration due to gravity also positive. According to the sign convention that I have chosen, I'm taking downwards as positive. Why? Because even if I take downwards as negative, then both will be negative and negative sign will be cancelled. Is t square. So we have the value of time period 2h by t. This is the value of time period that you have. Note it down. Then we'll see the formula for range of motion. Range of motion here in horizontal projection is very easy. Even the time period and rest of the formulas are also easy. Note this down. From here, Martin, you also write it. And if you're not able to understand anything, please let me know. Now range of motion. So range is what? Range is the maximum horizontal displacement that is covered. So this is less, a little less in comparison to your angular projection. So derivation of this is also very easy. See, if you write the equation, x is equal to ut plus half at squared. So we have to talk everything with reference to x-axis. So this becomes ux and acceleration also becomes x-axis. I hope my voice is audible to all of you. It's not breaking in between. Actually, it's heavily raining in Delhi. So that's why it might happen the network issues are there. So please let me know if my voice cracks in between. Right now, it's fine?
Yes, ma'am.
All right. So yes, ux, velocity along x-axis is u only. T, now we know the time period. We have the value of time period under root 2h by g. Acceleration along x-axis. We have no acceleration along x-axis when we are talking about a projectile motion. And what is the displacement that we are trying to find? It is actually the range of motion. That's why we have taken x-axis. We didn't take y-axis this time. We took x-axis because we have to find out range of motion, which is situated along x-axis only. Now put in everything here, range of motion, ux, that is u, time period, this is 2h by g. And this entire term is in any way 0. So this is the formula for range of motion. Quickly note it down as well. Then we'll see, we just have to discuss velocity and then a question we'll discuss. Note down this as well. I hope you all have written that part. If still this is left, please let me know. I'll scroll up back. Now, last topic, velocity at any instant. So velocity at any instant is also similar. The procedures will be the same. The steps will be the same. So suppose at this point, I have chosen a random point and the direction of velocity is v. Now this is a random point. So now I need the velocities along x-axis and velocities along y-axis, right? Where the time period is t. So let's talk about x-axis first. Now velocity along x-axis, we already know what is our answer for velocity along x-axis because we have seen that component doesn't change. But still, if we go by the derivation, ux plus v is equal to u plus at. So this becomes ux plus axt. See, initial velocity along x-axis, we know this is u, and acceleration is 0. So along x-axis, it will still be ux only. Final velocity will be similar to initial velocity, that is u. Regarding y-axis, see, along y-axis, if we talk about, now we have to take vy. Vy is equal to uy plus ayt. V is equal to u plus at. Now uy velocity along y-axis, this is 0. Acceleration along y-axis is acceleration due to gravity. So this term becomes 0. So your vy will become gt. This is the value. Now, if you have to find out net velocity, if you have to find out the magnitude of velocity, so you will be solving the way you solve two vectors. Two vectors, if they are perpendicular, let's say this is the vector vxi cap plus vyj cap. How do you find its magnitude? You take the under root square of coefficient of I cap plus coefficient of j cap. This is how you take. And if we have to find out the direction for tan theta, we write it as vy by vx. This is all your basics of vectors, parallelogram we have done. This you should be able to recall. Now quickly note it down, then one question we'll practice and then this lesson will be over. Yes, yes. In the last year, the theta that we are taking, this is the angle that we consider when we are taking the consideration of parallelogram law. This is not the angle of projection. This is, yes, you are right. See, if this is V, this is Vx, this is Vy. So this we are talking about.
Okay, ma'am.
All those who have written till here, at least try this question. Try with this question. This is a very easy question. I'll discuss it. But at least the answers you should send it by yourself first.
Ma'am, in this question, we need to use the 2h by g one, right? Root 2h by g.
Yes, Sarah, which part you saying?
About the second question, we need
Range
to,
of motion. For
yeah,
the,
yeah.
we have to actually calculate the range of motion only, no? So whatever first part your answer is coming, no, a time period, just multiply it with the initial velocity, because what is the formula of range? It is u into under root 2h by g. And what is under root 2h by? That is your time period only.
Now the first one, the formula is time of flight.
How much you getting for the first part, Martin?
No, ma'am, the formula is time of flight, right?
Time of flight, yes, under root 2h by g. Wait, let me now discuss it with you. Formula C, an aeroplane flying at an altitude of 100 meter with velocity 10 meter per second. So height is 100 meters. U, that is velocity, is 10 meters per second, drops a packet. So if aeroplane is moving and a packet is dropped, so we know this is a horizontal projection case because no angle is being made. Now answer to the first part, time taken. So time taken by the packet to reach from the aeroplane to the ground. This is time of flight, that is under root 2h by g. And class, one thing I'm telling you, whenever you are revising projectile motion, no, see, once you are studying, that is different thing. But once you are revising towards the end, towards the before examination time or towards the end of session, class, revise it parallel, like angular projections formula for time period, horizontal projections formula for time period. 2u sine theta by g will be there. Under root 2h by g will be here. Like this, remember, otherwise at the end you will mix up the formulas. Because in this lesson you have formulas. Yes, Martin?
Is it 2 root 5?
Yes, yes, correct. 2 root 5. 2 root 5 is the answer. Height is 100. G is also 10. So that is root 20, which you can write it as 2 root 5 seconds. Very good. Second part, maximum horizontal distance covered. This is talking about the range of motion. So actually you're trying to find the range of motion. This is actually so direct. See, time you have obtained, multiplied with the initial velocity, 20 root 5 should be the answer for the second part. Look how. Formula of range of motion is u under root 2h by g. U is 10. What is 2 under root 2h by g? This is 2 root 5. So your answer is 20 root 5 meters. Last part is asking the velocity, no? See, when it says velocity, you automatically have to tell velocity is for the along y-axis and x-axis. Vx, we have seen the formula, it was u only. So Vx will be 10 meter per second. Vy, what was the formula we derived? Gt. So acceleration due to gravity is 10. And time is 2 root 5, or you can take it as root 20 also. So that becomes 10 root 20 meter per second. Just to have this 10, that's why I'm just writing. Now, what is the final net velocity? That is Vx vector plus Vy vector. How do we find its magnitude? Take their coefficients and square it up. So this becomes, coefficient of this is 10 only, 10 square plus coefficient of this is 10 root 20 whole square meter per second. No, so 10, 100. From here you have 20 into 100. 20, 100, no? Please
Yes.
check this. Check this and let me know. Yes. This should be 100. This is 2000, 2100. Cross check and let me know. This is how you have to solve. And the questions on angular projection are very easy based upon this. You just have to perform the application of motion under gravity. Yes, class, whenever you are solving the questions related to angular projection, projectile, the entire lesson projectile motion, just have the concept of motion under gravity in your mind. All right, in the back of your mind, please have this concept, because sometimes they are needed. Like we see when we take the acceleration due to gravity, that is motion under gravity only. So if needed, if the question is very difficult, it will be just using the concept of motion in 1D, that is motion under gravity. Otherwise, everything we have discussed. Question you people have noted, no? Yes, Sarah, you were saying something? Note down the solution. Yes, Sarah, say.
Nothing, ma'am.
Yes, Sarah, what you saying?
Nothing, ma'am.
Okay, okay. Write it. Let me know once done. Just text me done in the chat column. Now from Tuesday, your laws of motion will be started. Please revise vectors. Again, I'm telling, throughout your laws of motion, we talk about forces only. And force is a vector quantity. So we'll be using the concepts of vectors, parallelogram law, resolution of vectors, cross product, dot product. That's why we had taken so much time and done vectors in detail.